and photoresistant, photomasks, and such things. So what we are trying to do, we are trying to replace these electrodes for 3D printed electrodes. And we found this conductive filament at Blackmagic 3D. It is a polylactic acid-based filament doped with graphene, and it is from the same. It's based on the same thermoplastic, so we don't have problem to printing in adherence of one layer to other. It has a volume resistive of 0.6 ohm centimeter, and it is a relatively cheap material. So we start with some rough geometries. We start with with IDs really rough now, with finger widths of 1 millimeter, finger space of 1 millimeter. And working on the 3D printer parameters, we could get better resolution to a maximum finger width of 300 microns and a maximum spacing of 500 microns. This maximum height is attached to the 3D printer, so we could get a 3D Z location of the printer of 100 microns. We will also perform a profilometry and determine a mean roughness, mean surface roughness of about 30 microns. This roughness is about the same roughness of the substrate, so it will not interfere on the microfluidics applications that we have in mind. We also perform some simple electronic characterization and determine a contact resistance of about 108 ohms and a sheet resistance of 50 ohms per square, which is a pretty good result because it's near to ITO values. The next step was then try to do a microfluidic device. We started with a with standard geometry with the ID above the interdigited electrodes. However, this kind of geometry couldn't be applied because there are always leakages, and when you are trying to seal in this way, you short-circuited the IDs. And one of the great advantages of this technique, you can change the geometry almost as you want. So we tried a new approach. We 3D printed the electrode as the wall of the channel, and the microfluid and the fluid will pass among the fingers, and we measured the response between them. With this idea, we get a working device, and when we perform an impedance spectroscopy on the basic tastes, we could get a really good distinction among them. And again, this is only 1 cm unit. If you want to go for a electronic tongue or other sensing devices, we have to deposit some nanofilm materials. However, it's interesting to point out that this device took less than 10 hours to be ready. Meanwhile, when you take account the electrode production and the microchannel production, we would easily take at least 1 week to have this working device. And since we are using the space between the interdigitates, we can potentially enhance the frequency response, as we have a large contact area with the fluid. So we saw that the 3D printing is a very versatile technique, which enables a fast, efficient, and cheap prototyping methodology. We can easily integrate with traditional methods as PDMS, example, making molds for PDMS. We can get actual functional devices, and now we can 3D printed electrodes with some electrical response near to ITO, and again we can straightforward replicate these devices because it's a fully automated process. I'd like to thank all the people from the group and the external collaborators and the funding agents that make this project available. Thank you.
Thank you, Gabriel. We have time for one quick question.
Thank you so much, Gabriel, for a very nice presentation. It's very impressive device and results, mainly related with the 3D electrodes printing. I would like, if it's possible, talk a little about the mechanical properties of this 3D carbon printing electrode, if they are good, if you have issues with exfoliation or adhesion of these electrodes with the other parts of your device.
We didn't perform quantitative mechanical experiments on these 3D electrodes, but since they are the same material of the substrate, the polylactic acid, we don't expect to have any kind of delamination of the electrode.
They will be at the poster section also, and thanks Gabriel again. And we have just a message from Fracassi.
Pessoal, a gente tem agora a sessão de pôster no auditório 3 e junto com a sessão de pôster a gente vai ter também um coffee break ali no saguão. Só que o pessoal aqui do Centro de Convenções pediu para vocês não entrarem no auditório, né, com comida e bebida, tá? Então evitem de levar o material, qualquer coisa de comida lá para dentro do auditório, tá? Aproveitem para discutir bastante, né, com todos os presentes aqui no workshop. Obrigado pela presença.